Hey, have you ever wondered why a really catchy song just gets stuck in your head? Well, it's not just the melody, it's the rhythm. And that rhythm, it's like a hidden language, a secret mathematical code that connects the music you love to the very same principles that build bridges and create incredible works of art. Today, we're going to decode it together. So, let's just start with that big question. What in the world ties these seemingly separate fields together? Well, the answer is something we all kind of feel intuitively, right? It's this universal pulse that feels almost hardwired into us. It's all about rhythm. At its very core, rhythm is basically the heartbeat of time. It's that steady, predictable pulse that gives music its structure, its very life. But here's the thing. That same pulse, that same idea of an organizing, repeating pattern is the blueprint for tons of other systems out there. Just look at this comparison. In music, we group beats into what we call measures, like that familiar 1, 2, 3, 4 you hear in almost every pop song. What's so fascinating is that this isn't just a metaphor for a math pattern. It is one. Seriously. Think about a clock. The hours go from 1 to 12, and then what happens? They cycle right back to 1. That's a mathematical cycle. A musical measure does the exact same thing, creating this predictable, repeating loop that our brains just love to follow. Okay, so we've got this steady, cycling pulse. But how do we build more complex ideas on top of it? Well, that's where the notes themselves come in. And as it turns out, learning to read musical notes is basically a secret math lesson in disguise. So every single note has what's called a value, which is really just a fancy way of saying it represents a specific slice of time. And it's not an estimate, it's a super precise measurement that lets composers build these incredibly intricate patterns from that simple underlying beat. And here are the main players in our little rhythmic orchestra. It all starts with the whole note, this big open circle that lasts for 4 whole beats. From there, everything divides perfectly in 2. And you can see this visual shorthand, right? The half note gets a stem, the quarter note gets filled in solid, and as the notes get even shorter, they start collecting these little flags. It's simple. The busier the note looks, the faster it goes. This table just shows the beautiful, clean math of it all. One single whole note is this little universe that can hold exactly 2 half notes, or 4 quarter notes, or 8 eighth notes, and so on. It's a perfect binary system. You can even think of it like a rhythmic tree, where every single branch splits flawlessly in 2.
So here it is, the crucial point. When a musician is mastering rhythm, they are literally doing fractions. They are constantly adding, dividing, and swapping out values to make sure everything fits perfectly inside the measure. It's this physical, audible way to build a really powerful gut-level intuition for how proportions work.
All right, so we've talked a lot about the sounds, but what about the silence? In music, the moments between the notes, they aren't just empty air. They're actually a structural element, a really powerful tool that composers use to create tension, drama, and meaning. These measured silences are called rests, and just like notes, they have very precise durations. For every single note value we just saw, there's an equivalent rest. So a quarter note gets 1 beat of sound, and a quarter rest gets 1 beat of carefully controlled silence. And this is where the connection to visual art becomes so incredibly clear. In a great painting or a beautiful piece of design, the empty space around the subject, the negative space, is used intentionally. It creates balance, it directs your eye, it makes the subject really pop. Well, musical rests are the invisible architecture of sound doing the exact same thing for our ears. Think about it for a second. That sudden pause in a song that just gives you goosebumps, that's a rest. That moment of total quiet that makes the next note feel like a huge explosion of sound, also a rest. Composers use rests like a painter uses shadows to create depth and drama and emotion. Silence is never empty. It's actually the canvas for sound. Okay, so we can divide time and we can sculpt with silence. But what if we need rhythms that don't fit into these neat little boxes? How do we build custom length notes? For that, we need 2 little tools. And to understand them, we're going to start thinking like engineers. First up is the dot. This tiny little mark next to a note has a huge job. It's a really simple, elegant mathematical instruction that just says, increase this note's length by half of its original value. So a half note, which is normally 2 beats, gets a dot, you add half of 2, which is 1, and now it's worth 3 beats total. Simple as that. Next up, we have the tie. This little curved line physically links two notes of the same pitch, and its function is even more direct. Just add their values together. You play them as one single, unbroken sound. It's how you get those long, soaring, sustained notes that can flow right over the boundaries of a measure. And this right here is where the engineering analogy gets so cool. A dot basically acts like a modifying coefficient in an equation, changing a component's properties by a precise 50%. A tie, well, that's like a welder's torch, fusing two separate steel beams into one single, powerful, continuous unit. See? Musicians aren't just artists, they are literally engineers of time. So when we step back and look at the big picture, these aren't just musical concepts, they're universal themes. Pattern recognition, proportional thinking, meaningful absence, and structural combination. This isn't just a music theory lesson, it's a fundamental toolkit for how we analyze and build our entire world. So what does this all actually mean for you? Well, these aren't just abstract ideas to admire from a distance. These are practical, hands-on tools you can use to see the world and maybe your own field of study in a completely new light. The only question is, are you ready to become a pattern finder? Ready to hear the math in the music and see the rhythm in everything else? Here are a few challenges to put your new toolkit to the test. For you math folks out there, grab a piece of sheet music and try converting a measure into a series of fractions. Do they all add up? For the writers, find a favorite poem and map its meter. Its stressed and unstressed syllables. You'll find it has its own 4/4 or 3/4 time. For the artists, create a design where the empty space is actually the most powerful element. And for the engineers, try to sketch out how a dot could add 50% more capacity to some component or how a tie could join two supports. The connections are literally everywhere once you start looking for them. And that really is the ultimate point. Learning the language of rhythm isn't just for musicians. It's a fundamental discipline that sharpens all of our minds. It enhances analytical thinking, it deepens pattern recognition, and it supercharges creative problem solving, no matter what you do. It's the universal pulse that connects us all.